Hi friends, welcome to Biology Tutor. Today we are going to discuss about tests for milk quality, detection of adulterants, plant hygiene and sanitation. If you like this channel, please share and subscribe. Don't forget to click the bell button for notifications. Enroll for free online mock test series at www.microbiologytutor.com. Quality assessment of raw milk. The quality of the incoming raw milk is assessed to check its suitability for processing through various Q tests called platform test. Q tests to check the quality of the milk are known as platform tests. Visual and sensory tests. Milk is screened for the presence of any objectionable material floating on the top of the container or objectionable taste. That this test to detect these material are known as visual and sensory tests. Sediment test to test or assess the cleanliness of milk and is performed by using a sediment tester. Quality of sediments is 2 mg means poor quality, no sediments means excellent quality. Clot on boiling COB test, it is used to indicate the suitability of milk for pasteurization and other heat treatment processes. Formation of flakes or clots on boiling, unsuitable for pasteurization. Alcohol test. This test used to indicate the suitability of milk for high heat processing such as condensing and UHT processing. Ethyl alcohol is used over here. Formation of flakes or clots means abnormal milk quality. Alcohol alizarin test. What is alcohol alizarin test? Indicate the suitability of milk for high heat treatment and also gives an idea about its acidity. Alcohol alizarin solution 0.2% is used over here. Formation of flakes and color is observed. Color lilac means up to 0.14% lactic acid. Heat stability is good. Just read this table. Quality of milk, chemical quality and microbiological quality. Chemical quality of milk, chemical tests performed in order to meet the mandatory standards for legal requirements constitute testing for major components of milk and milk products. They are fat, total solids, lactose, protein, moisture and ash content. Determination of fat. Fat is an important and valuable constituent of milk and plays an important role in pricing of the milk. Estimation of fat in milk is done in two different methods. First one is Gerber method. Gerber method is used to detect the fat content of milk. It is volumetric method. Reagents used are Gerber sulfuric acid and amyl alcohol. Instrument used is Gerber centrifuge. Gerber butyrometers are also used. Ross-Gottlieb method, the second method. Gravimetric method. Ross-Gottlieb method is a gravimetric method. Reagents used here are concentrated ammonia solution, concentrated HCl, ethyl alcohol, diethyl ether and petroleum ether. Apparatus used are fat extraction apparatus or Ross-Gottlieb tube. Acid digestion method is there. Werner-Schmidt method, it is also known as Werner-Schmidt method. Reagents used are HCl, alcohol, ethyl ether or petroleum ether. Determination of solids not fat content or SNF test using lactometer. The SNF content of milk is calculated by determining the specific gravity of the milk. Lactometer is based on Archimedes' principle. Lactometer calibrated at 27 degrees Celsius. According to Bureau of Indian Standard, total solids can also be determined using lactometer. Richmond formula is used for calculating SNF or TS percentage. Determination of total solids. TS of milk is determined by gravimetric method. By evaporating water from the milk under controlled conditions, the total solid content can be determined accurately. Determination of lactose contents. The lactose in milk and milk products can be quantified by methods based on one of the five principles. The first one is polarimetry, the second one oxidation reduction titration, it is also known as Lane-Eignon method, and the third one is colorimetry, and the fourth one chromatography, and the last one enzymatic method. The first one is polarimetric method. It is a simple and very accurate. Lane-Eignon method. It is the most commonly used and widely accepted method. The name of that method is Lane-Eignon method. It is based on the principle of reduction of Fehling solution by reducing sugars. Determination of protein content. The standard method for determining the percentage protein content in milk is Geldahl method. It analyzes total nitrogen content. Protein nitrogen derived from amino acids. 95% of nitrogen in milk. Non-protein nitrogen such as urea of 5%. Protein measure protein content is equal to total nitrogen content by Geldahl method into a conversion factor that is known as Jones factor. The conversion factor of 6.38 is specific for milk. Total ash content. Milk contains soluble salts like sodium, potassium, calcium, phosphorus, citrates, sulfates, chlorides, carbonates, magnesium, etc. Heating milk at higher temperatures decomposes organic matter and the soluble inorganic salts are left in the form of ash. Milk is heated at 550 degrees Celsius until ash is free from carbon. Then ash is weighed over here. That is a method to detect the total ash content in milk. Microbiological quality of milk. Main methods used are dye reduction tests, then microbiological enumeration methods. First, dye reduction tests. The basis of the dye reduction test is the ability of the bacteria to produce enzymes which can transfer hydrogen from a substrate to a redox dye which undergoes change in color. The reduction time is inversely related to the bacterial count of the sample. First method is methylene blue reduction test. Methylene blue reduction test. Methylene blue is in blue color in oxidized state, but the color is reduced to colorless by the metabolic activity of bacteria in milk. The time required for reduction is influenced by number and type of bacteria present in the milk. Time 5 hours and above. The grade is very good. Time 3 to 4 hours means grade is good. 1 to 2 hours the grade is fair. 0.5 and below the grade of the milk is very poor. This is according to the Bureau of Indian Standard Guidelines for MBRT. Rizazurin reduction test. Rizazurin acts as an oxidation reduction indicator. The changes in color take place in two stages. First, blue color of rizazurin changes to pink due to compound rizofurin. The second step, the rizofurin is reduced to hydrorizofurin, which is in white in color. Color changes can be compared with standard color disc and expressed in terms of disc number. It can be performed for 10 minutes, 1 hour or 3 hours. Due to short time requirement, it can be used as a platform test of milk. Right side you can see a table which consists of disc number, milk quality and other remarks. Please read the table. Microbial enumeration methods. Direct methods are used like count cell microscopically or examine ability of the viable cells to grow and form colonies. More sensitive and accurate than indirect method, but it is time consuming one. Most widely used method is the plate count method. It takes 24 to 72 hours to get proper results. Adulteration of milk. Common adulterants in milk are carbohydrates, salts and fertilizers, neutralizers, preservatives, detergents and water. Carbohydrates. Cane sugar in milk. How to determine the amount of cane sugar in milk? It is detected by Selivanov's method. Fructose in cane sugar reacts with resorcinol in hydrochloric acid to give red color. Starch. How to detect starch? It is added in milk to raise the SNF content. It is easily detected by using iodine solution. Next, the cellulose. It gives blue color with iodine. Here, zinc chloride reagent is used. How to detect glucose? Here, Barford test is used to detect glucose. Dextrin or maltodextrin. Iodine solution is used. Chocolate red-brown color indicates the presence of dextrin or maltodextrin in milk. Next, the salts and fertilizers. Urea. For detecting the presence of urea, 3 methods are used. Mainly 2 methods are used. One more additional steps are here. The first A uses paradimethyl aminobenzaldehyde or DMAB solution. Intense yellow color indicates the presence of urea. The second one, urease and bromothymol blue solution are used. Appearance of blue color indicates adulteration. Using TCA, sodium hypochlorite, sodium hydroxide and phenol solution, a blue or bluish green color indicates the presence of urea. Ammonium compounds. It is used to detect detected by using Nessler's reagent. Common salt. Silver nitrate and potassium chromate are used. Yellow color indicates excess salt and red color means no adulteration has happened to the milk. Sulfates added to milk to raise its SNF level in milk. It can be detected by using barium chloride. Neutralizers. In milk, sodium hydroxide, sodium carbonate and sodium bicarbonate are added to neutralize the developed acidity in milk. Rosalic acid test or soda test. Deep rose red color which indicates addition of sodium hydroxide, potassium hydroxide and or calcium hydroxide. Pink color, addition of sodium bicarbonate, potassium carbonate or calcium carbonate. These things can be tested using rosalic acid test. Alkalinity test. Test alkalinity of ash. Alkalinity test is used to test the alkalinity of the ash. preservatives, boric acid and borates. A strip of turmeric paper is used. Red color indicates the presence of boric acid or its salt. Formalin or formaldehyde added in milk as preservative as it checks the rise in acidity. Two tests are used. Hechner test. What is Hechner test? It is used to detect the presence of formalin in milk. Ferric chloride and concentrated sulfuric acid are used over here. Presence of violet colored ring at the junction of two liquids indicates the presence of formaldehyde in milk. Hechner test. Next, the Schiller's test. Ferric chloride and concentrated hydrochloric acid are used over here. Violet color indicates the presence of formaldehyde. Next, the hydrogen peroxide. It acts as an antimicrobial agent, thereby checking the development of acidity. Reagent used paraphenyl diamine hydrochloride. Intense blue color indicates the presence of hydrogen peroxide. Detergents. Methylene blue dye and chloroform are used. Intense blue color indicates the presence of detergents in milk. Detection of pulverized soap. Phenolphthalein indicator is used. Development of pink color in the presence of phenolphthalein indicates that the milk is adulterated with soap solution. Water. Adulteration with water is indicated by lower percentage of fat, lower percentage of SNF, lower density reading, depression of freezing point. Pond water. How to detect the presence of pond water? Here, diphenylamine solution is used. The presence of blue color in the presence of diphenylamine indicates the presence of pond water. It detects nitrates in pond water. Other tests. Bowdoin test. It is used to detect the presence of sesame oil in ghee. Skimmed milk powder in natural milk. How to detect the presence of skimmed milk powder in natural milk? Skimmed milk powder is not allowed for adjustment of SNF in case of sale of cow or buffalo or mixed milk. Here reagents used are acetic acid, phosphomolybdic acid. Bluish color indicates adulteration with skimmed milk powder in natural milk. Instruments used in analysis of milk are milk cod tester. It is used to determine the fat percentage in milk. Infrared milk analyzer or milk cow scan. It is used to analyze important parameters like fat, protein, total solids and lactose contents in milk within seconds. Lactostar automatic milk analyzer. Determination of fat, SNF, protein, lactose and freezing point of milk can be detected using Lactostar automatic milk analyzer. Next, the Pro Milk MK2. It is used to determine the protein in milk by dye binding method. Dyes used are Amidoblack 10B, acid orange 12 and orange G. Next, the bactoscope or somascope. It is used to determine the total bacterial count or somatic cells present in the milk. Next, Rancimet. What is Rancimet? It is used to detect the oxidative stability and rough estimation of the shelf life of products. Lactometer. Find the amount of water in the milk. Butyro refractometer. Butyro measures the refractive index of fats and oils. Flame photometer, it is very important. It is used to determine the calcium, sodium and potassium in milk and other milk products. Atomic absorption spectrophotometer. This machine or instrument or technique is capable of determining the trace and ultra trace levels of elements or metals. Now it has been replaced with ICP-MS. Cleaning and sanitization. Cleaning, removal of soil from the surface of the equipment. Sanitization, destruction of all pathogenic and almost all non-pathogenic organisms. That means sanitization. Next, the dairy soil. These are milk constituents that deposited on the surface of equipment during the course of processing. Dairy soils are composed of ash content of 42 to 67%, fat of 3.6 to 18%, protein 4.5 to 44%, and moisture content of 2.7 to 8.7%. Milk stones, larger and harder particles formed by continuous deposition of the dairy soil. For cleaning, detergents are used. Detergents. They are divided into four general classes. First one is alkaline detergents. Commonly used ones are sodium hydroxide, sodium bicarbonate up to trisodium phosphate. More recent ones used for specialized cleaning purposes are sodium metasilicate and sodium hexametaphosphate. A mixture of 5 to 10% calgon plus caustic soda to give 1.5% alkalinity. It is good for cleaning milk bottles. Synthetic detergents. They have good surface active and emulsifying properties and improve wetting or penetrating power by lowering the surface tension of water. Acid cleaners. Weak solutions of about 0.1% acids are used over here. Most commonly used are phosphoric and nitric acids. Next, the water softeners. Hard water is not suitable for cleaning operations. Hardness of water is removed by replacing 5 to 10 parts of soda ash in the detergent mixture with an equivalent proportion of calgon. Sanitizers. Sanitization is the destruction of pathogens and aims at reducing microorganisms to a level acceptable by public health authorities. Classified into three main types: thermal, radiation and chemical ones. The first one is thermal sanitizers. Heat increases the speed of chemical actions over here, the dissolving capacity and solute holding capacity of water. Heat is applied by using hot air or hot water or steam over here. Next, the radiation. Ultraviolet, high energy cathode or gamma rays are used. UV radiations are very useful on heat sensitive surfaces such as flexible packing materials. Chemical sanitizers. They are also called low temperature sanitizers. Most commonly used chemical sanitizers in dairy industry are chlorine, iodine and quaternary ammonium compounds. Chlorine based sanitizers. Advantages of chlorine based sanitizers: active at very low temperature, is relatively cheap, leaves minimal residue or film on surfaces. It is non-toxic, practically colorless, odorless and tasteless. Disadvantage: corrosive, corrosive at higher temperatures. Commonly used: liquid chlorine, hypochlorites, inorganic chloramines and organic chloramines are used. Hypochlorites, minimum concentration of 50 ppm for 1 minute at a temperature of 24 degrees Celsius are highly recommended. Chloramines 200 ppm for 1 minute is recommended. Iodine usually complexed with a surfactant as a carrier called iodophores. They have broad spectrum activity against bacteria, viruses, yeast, molds and other protozoans. Recommended dosage for iodophores 12.5 to 25 ppm for 1 minute. Next, the quaternary ammonium compounds. They are neutral disinfectants. They are positively charged cations. Their mode of action is related to their attraction to negatively charged materials such as bacterial proteins. They are more active against gram-positive bacteria than gram-negative bacteria. They are more active at alkaline pH. Cleaning and sanitization protocols. Cleaning in place or CIP systems. Circulation of cleaning liquids through interior surface of pipelines, vessels, filters, process equipment and associated things without dismantling the equipment. That is known as CIP systems. Cleaning and sterilizing liquids used in CIP systems are mainly alkali or acid based. Types of CIP systems. A. Based on area of application. Distributed system, central system. Distributed system. Individual sections of the plant can be cleaned with a local dedicated unit, that is known as distributed system. Next, the central system. The complete process facility is supplied by a single centralized system, that is known as central system. B. Based on number of circuits, single use system. CIP solution is used once and then discarded to drain. Next, the multi-use system. CIP solution is recovered, restored and reused over here. CIP cycles for sanitization of surfaces of dairy apparatus, utensils and equipment involves certain well-defined steps. Purge or pre-rinse. Recovery of product residue by drainage and expulsion of non-retrievable residue in pre-rinse or purge. Washing with detergents. Removal of remaining soil, either caustic acid or both can be used. Final rinse. Flush out residual detergents or soil. Sterilant or sanitizer. Thermal disinfection of 90 to 95 degrees Celsius and cooling for 10 minutes or chemical disinfection with suitable sanitizers are performed. Clean out of place COP system. For parts of equipment which require disassembly for proper cleaning, parts are placed in a circulation tank and cleaned using a heated chemical solution and agitation. Sterilization in place SIP system. Essential units are sterilized in place. The steam used has to be extra pure and must pass through a microfilter before use. The steam quality and cleanliness must be maintained by the use of pressure grade stainless steel or Teflon light tubing. Thank you. If you like this channel, please share and subscribe. Don't forget to click the bell button for notification. Enroll for free online mock test at www.microbiologytutor.com.